2019 August past paper question, Combined Maths 1, matrix. Let matrix A, these are the elements. In the first row, A 0 minus 1, the second row 0 minus 1, 0. Matrix B, first row 2, 1, 3, 1, second row 1 minus A 4. And matrix C, first row B minus 2, second row minus 1 and B plus 1. B matrices such that A into transformation of B is equal C, where A comma B belongs to real numbers. Show that A is equal to and B is equal 1. Show also that inverse of C matrix does not exist. Last part, let P is equal half into C minus 2I, write down inverse of P inverse, and find the matrix Q such that 2P into Q plus 3I is equal P minus I, where I is the identity matrix of order 2. Solution for this question is the matrix B 2 by 3 order, 2 row and 3 columns. First column 2, 1, second column 1 minus A, and third column 3, 4. Transformation of this matrix B is in the first column 2, 1, 3, in the second column 1 minus A, comma 4. We already learned in our theory class. A into transformation of B, multiplication of two matrices. First matrix A and second matrix transformations of B. This is the matrix A, this is the transformation of B. When multiply these two matrices, this order 2 by 3 and this order 3 row and 2 column, 3 by 2. When multiply the order of this matrix, here 2, here 2. 2 by 2 matrix we will get. Now we will get 2 by 2 order. This has 4 elements. Here 1 element, here 1 element, here 1 element, here 1 element. 4 elements. Now we will calculate this element. This element multiply this first row into first column each element. That means A into 2, 2, 0 into 1, 0, minus 1 into 3, minus 3. When adding all these 2A minus 3, over here 2A minus 3, then this element will be get by multiplying this first row and this second column. Corresponding element we multiply then add it. A into 1 A, 0 into minus A, 0, minus 1 into 4, minus 4. Therefore A minus 4 this one. And this element, how to get this element? The second row should be multiplied first column. 0 into 2, 0, minus 1 into 1, minus 1, 0 into 3, 0. Therefore, minus 1 into 1, minus 1. Here, minus 1. And this element, how to get this element? The second row should be multiplied by the second column. 0 into 1, 0, minus 1 into minus A, 0 into 4, 0. Therefore, this one, A. So, this is the A transformations of B. 2A minus 3, A minus 4, minus 1 and A. And also it is given A into transformations of B is equal matrix C. We must show that A is equal to and B is equal 1. For this one, A into transformations of B, we can put this one, this matrix. And for C, here we are given C this matrix. 4 elements. B minus 2 minus 1, B plus 1. These two matrices, corresponding elements are equal. Equating corresponding elements, this one A minus 4 is equal to minus 2. Therefore, A is equal to, and this 2A minus 3 is equal to this B. Therefore, B is equal, A is 2. Therefore, 2 into 2, 4. 4 minus 3, 1. Therefore, B is equal 1. In this part, this is the matrix C. It is given matrix C. Matrix C is B minus 2 minus 1 B plus 1, but we already know B is equal 1. Therefore, this one 1 minus 2 minus 1 1 plus 1 2. Therefore, this is the matrix C. We must show C inverse does not exist. Determinant of C is calculated in this way. Determinant is within the parallel lines. 1 minus 1 minus 2, 2. We already know how to calculate this one. 1 into 2 minus, multiply this one, minus 1 into minus 2. 1 into 2 minus 2, this is 0. Determinant of C is equal 0, therefore C inverse does not exist. So that by the definition, C inverse is equal 1 over determinant C into matrix C. But determinant is 0, therefore C inverse does not exist. Then this part, last part, identity matrix, 2 order identity matrix, this one, 1, 0, 0, 1. Therefore, 2i, each element should be multiplied by 2. Therefore, 2, 0, 0, 2 is a 2i. But we are given matrix P is equal half into C minus 2i. Therefore, half into, for this matrix C, this one, 1 minus 2 minus 1, 2. 1 minus 2 minus 1 2 minus into, for this 2i we can substitute this matrix 2 0 0 comma 2. When simplifying this one, half outside into corresponding element should be subtracted. 1 minus 2 minus 1, this minus 2 minus 0 minus 2, minus 1 minus 0 minus 1, 2 minus 2 0. Outside half, when simplify further, this one, each element should be multiplied by half. Therefore, matrix P is equal minus half, minus 1, minus half and 0. You want to write it down? P inverse. How to find out the P inverse? We want to find out the determinants of P. So, determinants of P, multiply this one minus, multiply this element. Therefore, this into this one, 0 minus, minus 1 should be multiplied by minus half. Therefore, this one, minus into minus, plus into minus, minus half. Determinant of P. The P inverse 1 over determinant P into this matrix is 0, 1, half and minus half. This one interchange and this one should be multiplied minus. This element interchange. This diagonal should be multiplied minus. Minus 1 into minus 1, minus half into minus half. The P inverse. When simplify this one, determinant of P minus half. There 1 over determinant P is equal minus 2 into this matrix 0, 1, half, minus half. Each element should be multiplied by minus 2. Now this one, minus 2 into 0, 0, minus 2 into 1, minus 2, minus 2 into half, minus 1, minus 2 into minus half, that is 1. This is the inverse of P, P inverse matrix. Then we are given one of the relationship, this one. 2P into Q plus 3I is equal P minus I. We want to find out the matrix Q. So multiply by P inverse, both sides of the equation. P inverse, 2P, P inverse, the Q plus 3I, the P to P inverse minus I into P inverse. A inverse is I, identity matrix. Therefore, here P into P inverse I. Therefore, 2I into Q plus 3I is equal P into P inverse I minus I P inverse. But we know I identity matrix into one of the matrix. That means I A is equal A. Therefore, this one I into one of the matrix. Therefore, this matrix will be get 2 into Q plus 3I using this technique. Is equal I minus by this technique IA is equal A, therefore I P inverse is equal P inverse. For I 1 0 0 1, for P inverse matrix we already calculated 0 minus 2 minus 1 1, 0 minus 2 minus 1 1. These two matrices should be subtracted. Corresponding elements should be subtracted. Therefore, 2 into q plus 3i is equal 1 minus 0, 1, 0 minus minus 2, 2, 0 minus minus 1, 1, 1 minus 1 is equal 0. Therefore, q plus 3i is equal half into here 2, come here half. 1, 2, 1, 0. Therefore, q is equal 3i subtracted this side. Each element should be multiplied by half. Therefore, half into 2, 1, half into 1, half into 0, 0, minus 3i, 3 into identity matrix, 1, 0, 0, 1. Now, when subtract corresponding elements, half minus 3. This one, 1 minus 0. This one, half minus 0. This one, 0 minus 3. So, this one q is equal half minus 3 minus 5 by 2, 1 minus 0, 1, half minus 0, half, 0 minus 3, minus 3. This is the matrix Q.